right, here we are in Unit 7, Lesson 3. This is covered in the book in chapters 7.6 and 7.7. So the first thing we're going to do is we're going to cover some basic definitions. So the first one is a monomial. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. All right. Make this smaller so you can see it. There we go. All right, that's what a monomial is. So for example, an example of a monomial would be 3x or 5a squared b cubed. Here, let me erase that so you can see. 5a squared b cubed. Both of those are monomials. A number, a variable, or a product, product means multiply, of numbers and variables with whole number exponents. So the exponents have to be whole numbers. Now, another example of a monomial is 6. Why is this a monomial? Okay, because it says a number, a variable, or a product of numbers. Well, this is a number, okay, but you also need to understand, remember that x to the 0 power equals 1. So technically this is the same as 6x to the 0 because x to the 0 is just 1. So just keep that in mind. All right, the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. That's what I just talked about. All right? The sum of the exponents of the variables. Okay, not, a constant has a degree of 0. Okay? So here, the degree of this monomial is 1 because the exponent of the x is a 1. This degree is 5. 3 plus 2 is 5. And this degree is 0. Okay? All right, what is a polynomial? A polynomial is a monomial or a sum or difference of monomials. All right, so a polynomial, for example, is a bunch of these combined. So for instance, 3x plus 5a squared b cubed minus 6. That's a polynomial. There's many variations of these that we're going to be going over. The degree of a polynomial is the degree of the term with the greatest degree. So in other words, it's the one with the biggest exponent. It's the monomial with the greatest degree. So what's the degree of this polynomial? Well, the degree of this is 1, the degree of this is 5, and the degree of this is 0. So the degree of this entire polynomial would be 5. We would take the largest degree. And then lastly, standard form of a polynomial. Standard form of a polynomial is written in order of degree, greatest to least. Okay. Now, when we're talking about standard form, we're talking about when we only have one variable. Okay, so for example, 5x to the 4th plus 3x cubed plus 6x squared minus 8x. Okay, so there's just one variable. It goes 4, 3, 2, 1. And now, you don't have to have an exponent. Like, you could not have the 3x cubed, and it still would be a polynomial in standard form, as long as it goes in order from greatest to least. The leading coefficient is the coefficient of the first term, if it's in standard form. So when in standard form, the coefficient of the first term. So what's the leading coefficient here? 5. The leading coefficient would be 5. All right. So now let's look at some special names for polynomials. Again, this is in your book on page 497, if you want to go look at it there. And actually, yeah, I'm going to have you fill that in from your book. So you need to go to your book and you need to fill that in on from page 497. You need to know what these are and know examples of them, okay? All right, so now we're just going to look at some practice problems. So this is page 499 in your book. Obviously, I just screenshotted it. So I'm just going to pick a handful of these and work them, and then we'll do more in class. All right. So for this section, it says, find the degree of each monomial. All right, so this one is 4, okay? This one is 1. This one is 3 plus 2 is 5 plus 1 is 6. What's the degree here? Okay, well, there's no variable, which means it's like x to the 0, so the degree is a 0. Remember, anytime you have a constant, the degree is 0. Okay, so that's how you do the degree of a monomial. You add up the exponents of the variables, and if it's a constant, it's 0. Now this says find the degree of each polynomial. Now remember, we don't add them up here, we choose the largest one. Okay, so what's the degree here? 2, 4, and 1. So the degree of this entire thing would be 4. We would say the degree was 4. Here, I have 2 plus 1 is 3, so the degree of this monomial is 3. The degree of this is 0, so it would be 3. Let's come down here. I have 3 and I have 6, so the degree of this polynomial would be 6. Then it says write each polynomial in standard form, then give the leading coefficient. All right, so number 41. 2.5 plus 4.9 t cubed minus 4t squared plus t. So I need to put it in order from greatest to least with the exponent. So I'm going to write this as 4.9 t cubed. Now make sure you pay attention to the sign in front. Next comes the squared, but that's a negative, so I have to make sure that I keep the minus sign there. So I've got my cubed, I've got my squared, now I'm going to go here, plus t, and then my constant is a positive number, there's no negative, so it's a plus 2.5. All right, let's look at 40, let's see, let's do 44. All right, 44. I'm not going to rewrite it. So negative m plus 7 minus 3m squared. So the greatest exponent is here, minus 3m squared. Then we've got the m, that's to the first power, so minus m, and then we've got the 0 power, which is plus 7. So that's really all that is, okay, just understanding what the degree is. If we're talking about a monomial, it's different than if we're talking about a polynomial, and then understanding what standard form is. All right, now we're going to move on to actually adding and subtracting these polynomials, which is really pretty simple. To add or subtract polynomials, all you need to do is combine like terms. Okay, be sure to line up the like terms before adding or subtracting. All right, so again, I'm going to do some example problems here for you. This is from page 507 in your book. All right, so it says we're just adding or subtracting. I'm going to teach you how to do it using, well, I'm going to show you both horizontal and vertical. It's the same thing, it's just a matter of which makes sense to you. If you remember back to elimination when we were solving systems, that's going to be like the vertical. So let's start with that one. Okay, so we're going to start with these right here. All right, so 2t squared minus 8t plus, now I want to line these up with their like terms. So 8t squared, those are like terms, plus 9t, those are like terms. Okay? So 2 plus 8 is 10t squared, negative 8 plus 9 is 1t. So that would be my answer, 10t squared plus 1t. So it's very important to understand what like terms are, okay? So let me back up for just a minute, and let's look at 16 through 24. Okay, so when there's just one variable, it should be pretty obvious what like terms are. K cubed and k squared cannot be combined. Okay, this cannot be added together because this is k to the third power and this is k to the second power. Whereas if you look down here, okay, this is tricky, number 20. 7xy, then we have negative 4x squared y, and then we have negative 2xy. These are like terms, okay? But this does not go with these two because the exponent is different, all right? So if I'm just looking at this, I can just combine this horizontally. So this is number 20. What's 7 minus 2? That's 5xy, and then minus 4x squared y. Now remember when we talked about standard form? We talked about standard form only when standard form only applies if there's only one variable. There are two variables here, okay? And so we don't have to rewrite this. That could be our answer. All right? Let's look at number 21. Negative 6x cubed plus 5x plus 2x cubed plus 4x cubed. So this guy and this guy and this guy all go together. Okay, so that's negative 6 plus 2 is negative 4, plus 4 is 0. Interesting. So now there's 0x cubed. So my answer is just 5x. Okay? All right, now let's look at, well, I already did that. Okay, let's look at number 26. I've got negative 7x squared minus 2x plus 3, and then plus, I'm adding all of this. So I'm going to write this out, negative 7x squared minus 2x plus 3. Now when you're looking at the first polynomial, it's much better if it's in standard form, which it is, 2, 1, 0, right? The exponents, 2, 1, 0. Now I'm going to actually draw columns here. Notice that the sign goes in the column. And I'm adding to this, what am I adding? I'm going to do a different color. I'm adding 4x squared, that goes here, and negative 9x goes here. Okay, I don't have anything here to add to this, so he's just going to stay like he is. So the result of that is going to be, let's do red, I guess. The result of that will be negative 7 plus 4 is negative 3x squared. Negative 2 plus negative 9 is negative 11x. 3 plus 0 is 3. So your final answer is negative 3x squared minus 11x plus 3. All right? So you really are just combining like terms is all you're doing. But you have to make sure that you combine the correct like terms. Now let's do a subtraction problem. So let's look at number 31. I have 5m plus 3, okay? Now look at this second one that I'm subtracting. Notice that there's a cubed and a squared. So when I write this, I want to leave space for that. So I'm going to have the cubed here. So this is going to be 6m cubed. This is going to be negative 2m squared. All right, do I have a cubed in the first one? No. Do I have a squared in the first one? No. So my 5m is going to go here, and my plus 3 is going to go here. and I'm subtracting this. I'm subtracting this minus this, but notice none of those are like terms. So what is my result? Well, these are zeros. So 0 minus 6m cubed is negative 6m cubed. 0 minus negative 2m squared is positive 2m squared. 5m minus 0 is 5m. That's a positive 5m. Make sure you have a sign. 3 minus 0 is positive 3. So my answer to this would just be negative 6m cubed plus 2m squared plus 5m plus 3. So when you subtract, make sure that you subtract everything. Again, it's very much like elimination that we did. All right, we'll do one more. We'll do number 32. So number 32 says, extend this a little bit more, make it a different color. Okay, 32 is, I'm going to rewrite it down here, 3s squared plus 4s minus negative 10s squared plus 6s. So what is our greatest degree? The biggest degree we have is a 2. So when I line them up, I'm going to have 2, 1, 0. Okay? So I'm going to have 3s squared plus 4s. This is a 0. I can put a 0 there. Minus negative 10s squared plus 6s plus 0. So this doesn't really matter, right? Because neither of them have that term. So 3 minus negative 10 is 13s squared. 4 minus 6 is negative 2s. So your answer would be 13s squared minus 2s. And that's it. That's all you do. Don't add things that should not be combined. Don't subtract things that shouldn't be combined. And that's pretty much it. So we'll do some more problems in class. Bring your book because we'll probably be using the book. See you in class.